During the session, I will explain how Java helps you keep your programs not just running, but improving for a very long period of time with little or no work from you. My name is Aurelio Garcia Ribeiro. I am a Senior Director of Java Standard Edition at Oracle. I have been with this group since it was part of Sun Microsystems. This year, Java is turning 26 years old, and it's arguably the most successful development platform. Even after all this time, it's still going strong. A lot of people want to know, what's its secret? What is so appealing about Java SE as a platform? To understand one of the most important benefits of Java, we need to understand how other development languages work. You write the code in your favorite language, then the compiler turns that code into machine code. The machine code is tied to the OS and architecture that you compiled it on. You're going to get a program that is ready to run on the same operating system and architecture. Now, some languages like C++ have compilers for different platforms. So you can, with the same source code, compile it in different platforms and get programs that will run on different architectures and operating systems. Now, you will need to get as many compilers as operating systems you want to support. And the resulting program is hardwired for that compiler and architectures, and for that operating system and architecture. When you use Java and other languages that use virtual machines, it works a little bit differently. You write your code, you compile it, but the compiler does not produce machine code. It produces bytecode. Now, bytecode cannot be run directly. It needs a Java virtual machine. Now, regardless of which operating system or architecture you compile it with, you can use the same bytecode on any virtual machine. So you can run it in as many platforms as you want, as long as there's a Java virtual machine available for that platform. And we have Java virtual machines available for all major platforms and operating systems. Now, when you download the JDK, you're going to get the Java virtual machine, the compiler, so you can turn your Java code into bytecode, a set of standard libraries, and additional tools for debugging, monitoring, and deploying your Java applications. When you update the Java virtual machine that you run in your programs to update to a new JDK release, this is the equivalent of grabbing some new hardware for free. So, running in an old computer without changing anything else, you just update the Java runtime and you're running on a new computer. The standard libraries are also very important. They do all of the very hard jobs, ones that require a lot of specialization to get right, like cryptography or floating point arithmetic. They also do the very common string manipulation and managing very large integers, so the ones that are common to pretty much every program. Updating the Java libraries is like having someone rewrite that part of your application. It is no longer the same program. It has been rewritten to use more modern techniques or to take advantage of improvements in the hardware. Let's see how this works. For example, let's say that you have a program that needs to figure out the day of the week, right? Now, you can do what I did without the libraries. You can go online and find some algorithm that will tell you how to compute the day of the week. Now, there's a German mathematician in the 1800s came up with this formula. His name was Christian Zeller, and it's relatively easy to code it. So I could write this in Java, and that's it, we'd be done. But no professional developer does this. Modern development languages have libraries that handle most of these common tasks. So developers will just grab the library and let the library do these conversions for them. When you use the Java libraries, you're saying, this part of the program, I don't want to manage myself. I'm happy to let somebody else not only do it for me the first time, but more importantly, I will let you update that part of the program if you can think of any improvement. The JDK has libraries for many different common tasks. For example, we have a collections library, which will give you lists, maps, and will give you highly optimized methods for managing items in each type of location. It will take into account whether you want to process them sequentially or in parallel. And you can change things without having to rebuild your application. The collections library received some massive rewrite with JDK 8 and the introduction of streams, for example. We have date and time libraries that will handle time zone conversions. They will help you figure out when an ISO week starts versus a region-specific week. They will interact with the ever-changing time zone database that can get updated very frequently. For example, in 2009, we had over 21 updates of the time zone database, and no developer wants to keep track of that. So you want a library to handle that for you. You have the new input-output libraries that will let you read files from different file systems, will handle pattern matching, and it will deal with the different platforms and the different ways that file systems work, say on Linux versus Windows or Mac. We have the networking classes that will handle TCP, UDP, and everything that you need to connect to other machines. This one is one of the most important ones. We have collections that will do cryptography, and they will manage things as connecting to different algorithms, calculating hashes, producing random numbers, and the like. We have libraries for connecting to databases, and we have libraries for supporting internationalization and localization. And this is not just a matter of having different text in different languages. It's considering details like how to accommodate languages that are written right to left or top to bottom. How do you format dates so that they match what the user wants to see? You can allow the input of compound characters, and you can determine the sort order we're using different locales. I mean, one of the examples that we have here is how would you sort those characters at the bottom? If you were to sort them alphabetically, they could all be the first letter of the name of some of your clients. A running Java application is the result of the collaboration of different components. We first think of the developers. They're the ones that write the application, and rightly so, they're the ones that create anything that's specific to your functionality. Now, developers usually need to bring in third-party libraries to handle some of the complex tasks that are not included in the JDK. A modern application can have tens or even hundreds of third-party dependencies. And there is then the Java runtime itself, which at a high level, you could say is the Java virtual machine and a collection of common libraries. Now, keep in mind that these third-party libraries, most of them rely themselves on the Java libraries. The developer code and the third-party libraries are under the control of the Java developer. They can only be updated when a new version of your application is available. The Java runtime, on the other hand, is provided by Oracle or from whomever builds your Java runtime, and allows system administrators to update the application independently of the developer. Here's an example. If back in the days of Java 1.4.2, I had written a Java application that used the JDK libraries to establish a secure connection, it would have just used SSL 3, which was at the time the industry standard. By updating to JDK 6, that same application will now run it will now connect using TLS 1.0 without the developer having to code anything or without having to recompile and redistribute the application. Once you move to JDK 17, the same application will connect with TLS 1.3. And in this way, sometime in the future, we can use an encryption algorithm that doesn't even exist when the application is written. All thanks to being able to update the runtime separately from the application. Another important part is how do you distribute your applications? If you write a Windows application, you can distribute it, and then Windows users can just grab it and run it. If you want to have the same application offered to users of other platforms, well, you would have to recompile the application, distribute those versions, and there you go. Your users can then run in those platforms. Now, if you want to update the compiled applications, well, now if you want to update the compiled applications, your developer will have to recompile, and then they will have to be redistributed. Now, even if the change was just to take advantage of an update to a library, you still have to go through these steps. When you have a Java application, on the other hand, you have two options. First, the developer just distributes the bytecode. Then the users grabbed a Java runtime from Oracle, and they can run the Java application with the same bytecode by grabbing different runtimes. You could have the same application being used by any number of users. Now, like before, the developer could come up with a new version of the Java application, and that would be redistributed, and that's needed, say, if your logic changes. But there's another option as well, which is if the user is relying on a Java runtime, without the developer updating, imagine that this application was running on Java 17, the users can update to a new version of the Java runtime, and the application itself works better. Now, which versions of Java can you update to? Let's look at the support roadmap. Normally, when you look at the roadmap, it looks something like this. Now, some releases are designated as long-term support, and there's a lot of overlap between them. Right now, we have 4 supported releases, 17, 11, 8, and 7. But what does being supported mean, right? How often are new updates released on those versions? We can turn this abstract roadmap into something more concrete. There's a page where we list all of our support versions, and it will give you the exact versions in java.com releases. You can look at it at this matrix format. Now, as you can see, right now, there's many options of which versions you could be running. You could be running in 17.01, 11.013, any, let's imagine that you're running in 11.013, right? That's a current release. Now, when January of 2022 comes around, we're going to produce update releases. You have choices as where to go. You could update within the same version of 11, or you could upgrade, that is, go from 11 to 17. There are different risks and different reasons why you want to do one. Updating within the same release is usually a very low risk and low complexity operation, right? You would want to update to take advantage of the incremental performance improvements, support of new OSs and library updates, and most importantly, for the updates in the cryptographic libraries. You want to apply these updates as soon as possible after each release. We produce new CPUs, that's critical patch updates, on the Tuesday closest to the 17th of January, April, July, and October. And if there ever was a security vulnerability that couldn't wait until the next CPU, we would produce the security alert. Now, for mission critical applications, you want to test these updates before applying them. But for most other use cases, you should just apply the update and monitor it and see. And if something goes wrong, you can just revert back, look at the release notes, and they'll probably tell you what has changed and what you need to change in your application. Here's a sample of the changes that are in the cryptographic roadmap, right? We're going to enable TLS 1.3 in July of 2022, and we'll disable SHA-1 sign jars sometime in 2022 as well. Now, upgrading, that is moving across release families, is low to medium risk and medium complexity. Now, when should you upgrade? You should upgrade when there is a performance gain on the newer version in an area that your application relies on. Or if the release family that you rely on is approaching end of service life and your product isn't. So before upgrading though, you will have to update libraries and tools, everything that your program relies on, to make sure to run on a version that, on the newer JDK version that you want to use. We recommend that you thoroughly test your product and the new libraries and tools against the new release. And unlike the first case, there is a risk that crossing releases will trigger some new warnings or errors. Now, there's a higher risk, but there's also a higher reward. We have some large improvements when you go across release families. For example, here's the startup time of a minimal Hello World application as seen from JDK 8 to JDK 13. Now, there's a bit of a regression with JDK 9 when we introduced the module system. But as you can see, we started working on it. And by the time we reached JDK 11, which is only 1 year after JDK 9, we're back to or better than the startup of JDK 8. If you're using lambdas, we see some similar improvements. When you use lambdas, the first lambda triggers a lot of setup work. So there's a performance penalty. And as you can see, that penalty was pretty much gone by JDK 11. And the difference between using lambdas and not using lambdas is now less than 5 milliseconds at startup. Here's another important improvement, the introduction of class data sharing, right? In blue, we have an application startup time without application class data sharing. And you can see how the performance improves over time. But with JDK 11, if you start using app CDS, you will see a much more dramatic improvement. Now, if startup is a big point for you, you should also look into the native image tool that we make available with GraalVM Enterprise Edition, which can compile your Java application all the way to native code. Then if you do that, you lose the option of updating the runtime separately. But if you're running in containers and you were never planning to update the runtimes anyway, this might be a great idea. Also, we're improving the garbage collection performance on every version. And we have to do this because over time, hardware evolves and the expectations of our users evolve. When I started working with Java, hundreds of megabytes was considered a very big heap. Now, a very big heap is measured in terabytes, and the number of cores have similarly increased. Now, for G1, which is the default garbage collector since JDK 9, we measured the middle of the road balance between. Now, for G1, which is the default garbage collector since JDK 9, we now have we have here the results of running an industry standard benchmark across various versions of Java. The blue and green bars correspond to the throughput and the application responsiveness. Throughput has improved by nearly 10% from JDK 8 to JDK 14, and the latency has improved by about 60% in the same time. Now, again, if the pause time is your concern, we have an even bigger option for you, which is setGC. We introduced a new garbage collector. Here, let's compare it. If we grab an application and we have different garbage collection algorithms, we are now seeing the distribution of the same benchmark running on parallel GC, G1, and the new setGC, showing the average percentile and max pause times. So even though setGC looks like 0, it's not really 0. If we look in more detail, we will see that the pause time is now under milliseconds, and the max pause time is under 2 milliseconds. Now, in some workloads, you do see a few percent of throughput benefits for G1 over setGC. And for very small heaps, like a few hundred megabytes, G1 is also better. So for now, there is not one garbage collector that will just work better for everything. We're working on it. The point of this presentation is to illustrate what are the benefits of using Java. If you update the Java runtime periodically, you will get better performance from improvements in the virtual machine, and your code will evolve over time through the use of updated libraries. Thank you. We've gotten a few questions through the QA widget. Let me try to address as many as we can on the remaining 8 minutes. There's two that I'm going to group together. I've got how does Oracle Java compare with OpenJDK, and related, how easy is it to change between Java runtime vendors? Let me start by saying OpenJDK is source code. There is no official OpenJDK binary, or there is no way of saying this OpenJDK binary complies with OpenJDK or anything like that. OpenJDK is an open source project where we have different code lines. We have a code line for the next version of the JDK, which is managed by Oracle. We're the lead for that project. There are projects for different ports. There are projects that are exploratory, where we go and look at things like Valhalla value types or Metropolis, compiler written in Java, that are just ideas that might eventually end up in the JDK. So once you have the code in OpenJDK, anybody you included could grab that code, compile it, and build their own version of, I'm using air quotes here, OpenJDK. Now, when you choose the source code, you get to choose things like, oh, which garbage collection algorithms I'm going to select for my build of OpenJDK. In many cases, vendors will decide to add additional fixes and capabilities. And depending on where in the project you are, if you're using some new version that's coming in, or the next version that's coming out, or one of the branches for the old LTS releases, you may have different fixes from different vendors. So it's not an OpenJDK build. People, when they say I'm using OpenJDK, they usually mean I'm grabbing a build by some vendor that it's based on OpenJDK. So I couldn't tell you that they're all the same, because they aren't. In some cases, some companies I know actually grab the source code, they tweak something themselves, and they run it internally. And that's certainly allowed, but that's not the same runtime that you would get if you grab the runtime, say, produced by Oracle. So how does Oracle Java compare with OpenJDK? Oracle Java is a binary that you can run on your system. OpenJDK is source code. The question also about how to change between Java runtime vendors is, are they all the same? They're based on the same source code, but they're not necessarily all the same, okay? And I see some questions coming in chat. I've been told, please use the QA widget. That's the one we're monitoring. Now, how is a JDK selected as a long-term version? Why are there some versions that are not LTS? The LTS releases are selected on a time base. So we're producing a new Java runtime, a new version, every 6 months, so twice a year. That is to accommodate mostly developers that want access to new features more quickly. And every so often, it used to be every 3 years, we've now proposed that it be every 2 years, we will designate one of those as long-term support. And this came to be because we have two different audiences. When we spoke with developers at developer conferences and we asked them, how often should a new version come out? You know, developers wanted new features as quickly as possible. They're like, if we could do them once a month, do that. We don't want to wait. On the other hand, when we talked with system administrators that had a bunch of Java versions and they wanted to update as infrequently as possible, when we asked them how often should a major release at the time come out, they were like, yeah, 3 years is too frequent. We want them every 10 years. We'd like the old stuff to continue working forever and never have to update. So with an LTS every 2 years supported for a long period, we hope to give both sides what they want. So developers grab new versions, people running on the Java runtime tend to meet on LTS releases. Similar question, you mentioned you should update new JDK versions if there was some major performance improvement. Does this mean we shouldn't be using JDK 17 yet if my program doesn't have that? Well, that distinction was for an existing Java application. If you are a developer, there are major advantages to using the latest releases. It's usually easier to write code in new major releases. We add new language features. So for example, if you're running before Java 8 and all of a sudden Java 8 introduced Lambda, previous applications that weren't written using Lambda, there was no benefit to them, but as a developer, you could write easier code. It's the same with other language improvements. So we've introduced records in JDK 16. If you want to use them on 17, it'll make your code easier to write. It will have no impact on applications that were written, say, on JDK 11 and were compiled. So there's two different use cases. New applications, anything that you're coding for now, it's usually best to use the latest release. Some people say stay on the latest LTS if you don't want to have to update those. That depends on your company. We get some companies that say, oh, should I all be using the same version across all of my company? And the answer is probably not. You probably want to have new code written in the latest LTS or even in the latest non-LTS release if there's one available. And your older applications, then you should apply those rules that I printed out with update them, apply new CPUs patches with every CPU, but you don't have to go to the next LTS. You will also discover if you want to go to the next LTS that sometimes the limiting factor is not the JDK itself or your code, but the third-party libraries that go in between. You may be ready to update, your code may be ready to update, but if you chose some third-party library that it's not yet certified with that version of the JDK, you may not be able to yet. Now, we've reached the top of the hour. I'm going to keep going a little longer. If you have to drop, we will make the recording available, but I've got a few more questions and I didn't want to leave those hanging. One of the questions is, how do I know here if there is a new version of Java? Can I get an update? Could I get an email? And yes, we at Oracle have a page. You have to look for Oracle Critical Patch Updates, and you could register your email and receive a notice whenever a new version, be it a CPU or a critical patch, a security alert. The security alert is versions that security vulnerability fixes that come out that cannot wait until the next CPU. We don't have those very often, but when we do, those are not on a timetable. They're just whenever we have to do them. In either case, you'll get an email. Now, if you register at that email, you will get a notice for every security alert or critical patch update for any Oracle product. You can also, if you're a subscriber, choose to receive an email that will be only for Java, and that will not only just tell you there's a new version, but will highlight what are the important changes on that new version. Let's see, can I use any existing JDK version for any application? Oracle makes the latest LTS release available under non-fee, so you can use that in production. You can use JDK 17 and use it in production at no cost. We used to have only the latest one. We have announced that we will maintain JDK 17 under a non-fee license, not just until the launch of JDK 18, which happens in March of next year, but all the way until the release of the next LTS in 2023, plus 1 year overlap, because we got feedback that people wanted not just the latest version, but also the latest LTS. So right now, if you're a customer, you can use any of those versions that I listed. If you just want a release that you can use gratis without having to become a customer, we offer JDK 17. When 18 comes out, it will also be made available under those terms. And same 19, et cetera, et cetera. When 21, JDK 21, the next LTS comes out in 2023, we will continue offering updates to JDK 17 for 1 year at the same time as 21. And at that point, some future version of JDK 17 will switch and become available only for customers. At that point, if you're not a customer, you should move to the next LTS. How do you decide when a Java library should be improved? So we have teams that keep track of all of the areas that we cover in the Java libraries. In some cases, there's new algorithms, for example, in the cryptographic libraries. So if a new version of TLS became available, we would work to have that available. And TLS is one of the libraries that we actually backport to all the releases. We would introduce those in updates for all the releases. There are other changes that are triggered, for example, by releases of new versions of the operating system. Let me give you an example. Apple has announced that will deprecate some of the APIs that were used for graphic libraries in Java in some future version. They've already deprecated, but they haven't removed it. Some of the graphic libraries that Java relies on. So we have already come up with a replacement. The JDK 17 comes up with a way of using Metal, which is Apple's replacement. Now, at some point, we will backport those APIs to older versions, say to JDK 11 or JDK 8, so that when Apple removes, rather than just deprecates, the libraries that we need right now, your JDK will continue to work. So that's another case on which, your application didn't change. You say, why can I just run it forever? Well, if you want to run it on a new version of the OS, you may have to update the runtime. Let's see, we may have time for a couple more. I apologize. We may be able to answer some of the longer questions, but we do have to end at some point. How can I get notifications? Okay, so there's a question here about GraalVM. I mentioned that one of the benefits of Java is to update the Java runtime on an existing application. GraalVM, when you use it, you lose that option. So to be clear, GraalVM has, if you will, two different ways of operating. GraalVM Enterprise Edition, the two biggest benefits are you can replace the just-in-time compiler. Remember that I mentioned that a Java application gets turned into machine code at runtime every time you run it. Java has different compilers that allows you to do that. We traditionally have what we call the C1 and C2 compilers. GraalVM Enterprise Edition introduces another compiler that has certain performance optimizations. So for certain workloads, it will give you better performance. There's another way of using GraalVM, which is using the native image compiler. Okay, when you use native image compiler, that just-in-time compilation doesn't happen when you run it, but it happens ahead of time. So if you use native image compiler, you turn your Java application into something that's very similar to that compile application that I described at the beginning. Turning it into bytecode for that particular runtime, for that particular operating system, happens ahead of time. And what you get is a runtime optimized for a particular platform. If you use native image tooling, you will not get bytecode that can be interpreted by any JDK, by any JVM. You'll get something specific to that architecture. Now, I said it was a benefit to be able to update. There's certain cases, for example, if you're running a Java application in a container where you were never going to update it anyways. You don't update containers. You just create a new one with a new version. So if you're in that situation, then you may say, oh, okay, since I'm never going to update the runtime anyways, and I do want to improve the performance, mostly at startup and memory usage, then you should really look into GraalVM native image, right? That's a big benefit for you. If you have a long-running application that you're going to start and keep running for weeks or months, maybe that's not a place where you would like to add that extra compilation ahead at the beginning. So it's a matter of, depending on your use case, it may be a good idea to do this. let's see. Okay, this is a relatively common question. I'm currently using JDK 8. If I upgrade JDK, should I upgrade to JDK 11 instead of upgrading to JDK 17 directly? And the answer is, as most answers in this case, is it depends. In general, I would say if you're running on JDK 8 and you're updating to a new version, you should try to go to the latest version. So yes, aim for JDK 17. If you wrote your Java application and you're not using any third-party libraries that require a particular JDK version, you probably want to go straight to 17. Now, in some cases, you will discover that some third-party library that you rely on does not yet support JDK 17, in which case you get to choose, right? Should I wait for that application, for that runtime, for that library to be updated to use 17, or should I go to 11 if there's a version that runs on 11? And that's not an answer that will be the same for every application in your company, right? If you have some application that, oh, there's some performance improvements that I really want to have, then yes, rather than waiting for the third-party library to update to 17, you could go to 11. In some cases, the third-party library is not, maintained very quickly, and waiting until it gets to 17 could add a couple of years to your migration. So in that case, you may consider switching to another third-party library that updates more frequently. And in the meantime, go to 11. We've answered most of the questions. I apologize if yours wasn't. We'll see if we can get back to you via email once we have the registration finished. With that, I'm going to, let's see, a couple more that coming. Oh, thank you. You're welcome. I hope you find this useful. At the end of the session, we got an extra question that we thought it would be a good idea to add. I was asked, do you consider running on JDK 7 a security risk? And the answer to that is, if you don't tell me which version of JDK 7, I don't have enough information to answer this. Down here, we have the list of releases. So right now, we have a version of 7 that it's current, that has all of the security vulnerability fixes available in any other version. So if you're running in 7 update 321, you have the same security vulnerability fixes that you do if you're running in 17.01. Well, the ones that apply to 7, that is. Whereas if you were running, say, 7 update 281, you would need to update to the latest version of 7 to be covered. So from a security point of view, you're better off running 7 update 321 than, say, 11.011. So it's not sufficient to be on a newer version in absolute terms. You have to be in the correct update. If you're running 7, however, there's another consideration, which is 7 is scheduled to reach end of life in July 2022. So if you're running 7 and you are running in 321 and you're going to apply the upcoming CPUs, security-wise, you're fine, but you should consider migrating to either 8, 11, or 17 before 7 reaches end of life. Thank you.